Welcome to solverfy.
We are given a positive integer, and we are given a random variable x, m, and in part A, we have to show the probability generating function is a certain form. So let m be a positive integer. We have that the random variable x, m, is defined so that xm equals n if the nth success occurs on the n plus nth independent Bernoulli trial. Each trial's probability of success p. Find the probability generating function. Notice that if the nth success occurs in the n plus nth trial, this implies there are n minus 1 successes in n plus m minus 1 trials. And there's a success on the n plus nth trial. And so what this tells us is that due to the number of successes among a fixed number of trials follows a binomial distribution. And so we have that probability xm is equal to k this is going to be where we have n minus 1 successes and n plus n minus 1 trials. Binomial distribution gives us that this is going to be n plus m, or in this case, we'll do k plus m minus 1, choose m minus 1 times p to the m minus 1, the number of successes, times, and then q to the k plus m minus 1 minus m minus 1 for the number of failures in the first n plus m minus 1 trials. And finally, because the trials are independent, we can simply multiply this by success on the n plus nth trial, which is just p. And so we have that this is equal to k plus n minus 1, choose m minus 1 times p to the m times q to the k, where q is equal to 1 minus p. And so the probability generating function for x is gx of x is the sum from k equals 0 to infinity of k plus m minus 1, choose m minus 1, p to the m, q to the k, times x to the k, which we can rewrite as p to the m times the sum from k equals 0 to infinity of k plus m minus 1, choose m minus 1, qx to the k, and we have from a table in the book that this is equal to p to the m times 1 over 1 minus qx to the kth power, not kth, but in this case the nth power, and so it follows that the generating function is going to be p to the m over 1 minus qx to the m, as we're told. So we've proven this is our answer. In part B, we're asked to use the results of the previous problem to find the expected value and the variance of xm. So recall that from the previous problem, the expected value is equal to g prime x m of 1. And so to find this value, we need to take the derivative of g prime x, and you can do this on your own. I'm going to pause here and do it. But in the end, we get the result of this is m p to the m times q over 1 minus q x to the n plus 1. And so it follows that the expected value of xm is m p to the m q over 1 minus q to the m plus 1. Recognize this is the same as m p to the m q over 1 minus q is just p to the m plus 1. And so this becomes mq over p is our expected value. To find the variance, recall from the previous problem that the variance of xm is going to be the second derivative of gxm evaluated at 1 plus g prime xm evaluated at 1 minus g prime xm evaluated at 1 squared. And so in order to calculate this, we calculate g double prime xm of x. You can either do this by hand or use your software. Either way, I'm going to pause now as I'm going to proceed. And so we have that second derivative is p to the m times q squared times m plus 1 all over 1 minus qx to the n plus 2 so we have that θ prime xm of 1 is equal to p to the m q squared m times m plus 1 over 1 minus q to the m plus 2. We know that 1 minus q is simply p, so it's going to be p to the m q squared m times m plus 1 over p to the m plus 2. And so this reduces to q squared m times m plus 1 over p squared. And therefore we have that the variance of xm is equal to q squared m times m plus 1 over p squared plus, and then we have mq over p and minus mq over p squared. This is equal to, we have m times, and I could simply factor this out, so we have m squared plus m minus m times q squared over p squared and plus mp q over p squared. And this reduces to n squared plus, and this is 0, so n squared times q squared plus npq over p squared. We factor out nq to get nq plus p over p squared and we can rewrite this knowing that q is 1 minus p, so this is mq times m minus p plus p over p squared, which is m squared q over p squared. So, slight mistake was made. This should be, instead of minus m squared here. And so this is now positive m q squared plus m pq, which is just mq times q plus p. And we know that q plus p is 1, so this reduces to mq over p squared.